Notice that subtracting matrices works the same way. You have to have matrices that are again the same size, and you match up entries, and you just subtract normally. So on this first one, it would be 3 minus 4 equals the first entry of the next one, which is -1. So adding and subtracting seems pretty straightforward. Seems like the same idea as how you add and subtract normally, so let's give it a try. Notice the first example, we can add or subtract the two matrices because they are the same exact size. Notice both matrices have 3 rows and 2 columns. That means our answer is also going to have 3 rows and 2 columns. So going entry by entry, let's see what we end up with. So first entry with first entry, we're adding 4 plus 9 was going to give us 13. Then we would go over to the next entry. -3 and -10 would give us -13 because we are adding. Keep going. Move on to your next entry. 7 and 0 added together just gives you 7. Keep on going. We have 2 and 5 added together is 7. Keep on going. Next set of entries is -6 and -1 added together is -7. Last entries that match up is we've got an 8 and a 6, which added together is 14. So that's our final answer, just adding matching entries. Notice in problem B, we actually can't do the addition or subtraction no matter what was between these two matrices because the two matrices are not the same size. The first matrix has 3 rows and 1 column. The second matrix has 2 rows and only 1 column. So this would be not possible because the matrices are of different sizes. So you'd say something like, not possible. Matrices are different sizes. And that is only going to be true for when we're adding and subtracting. Notice on our last example here, we do have a 2 by 2 matrix that we're subtracting by another 2 by 2 matrix. So this is possible. We will just end up with another 2 by 2 matrix. It's just that we need to remind ourselves that whenever you add or subtract, you are combining like terms. So we need to make sure that we combine like terms when we're adding matching entries here. So actually subtracting matching entries. So we've got a 2 minus a -1. So that'll turn into a +1, which will give us 3. Next, let's take a look what we've got when we look at the next set of entries. We've got a square root of 7 minus 5 square roots of 7. Well, 1 square roots of 7 minus 5 square roots of 7 will give us a -4 square roots of 7. And we were able to add or subtract those two because they were like terms. They both had a square root of 7 in them. Next one, we've got 3 square roots of 28 minus 2 square roots of 7. Be careful. It doesn't look like you can subtract those, but you actually can. 3 square roots of 28 minus 2 square roots of 7. You can actually do this because you can break down the 28 into 4 times 7. So you can take the square root of the 4 and it comes out as a 2, which then gets multiplied by the 3 and becomes a 6. But you are stuck with this remaining square root of 7. So with that remaining square root of 7, they are then like terms because now we have, let's see what we have. We have 6 square roots of 7 minus that original 2 square roots of 7, which hasn't been tampered with. So that gives us a total of 4 square roots of 7 if we just add and subtract normally, now that they're like terms. The last piece is probably the easiest. Let's see what we've got. We have, let's see, a negative 6 and a minus 2, which is going to give us negative 8. So there's our final answer.